Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math questions out of this book here, the official guide to the GRE, the revised general test. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 236. Page 236, and today is our lesson number 120. Let's take a look at it. On page 236, example number 2.8.2. 2.8.2 is what they call them. Is what they call it. We are given two equations of two lines. Line 1 has the equation of 4x plus 3y equals 13. You should have the book in front of you and read the thing with me. Line 1 we are told has the equation of 4x plus 3y equals 13. Line 2 we are told has an equation of x plus 2y equals 2. The question is very simple, very straightforward. The question is, where do these two lines intersect? And what does the graph look like if we were to plot these two lines and show the point of intersection? When we talk about a point of intersection of two lines whose equations we know, finding out their point of intersection is what it means is that we are looking for a value of x and a value of y which will work for equation 1 and 2 at the same time. I'll say it one more time. We have to solve for value of x and y which will satisfy both equations simultaneously at the same time, which is why they are called simultaneous equations. So let's do it. We're going to solve these two simultaneous equations and find out where they intersect. That's all. These are called simultaneous equations. And as always, if you have watched any of my previous videos in the past, if I misspell something, don't make a big fuss about it. I'm not a good speller. I'm not sure to spell correctly, and if it's not, just correct the spelling yourself. Okay? So, let's take the equation number 2. Let's call it equation 2. Let's call this one equation 1. Let's take our equation number 2 and multiply it by 4. Now, why do I want to multiply equation 2 by 4? Because somehow we have to make the coefficient of either x or the y same, so that we can cancel each other out by subtracting one from the other. Now, if you were to try to make the coefficient y same for both equations, what will end up happening is, listen carefully. If you would try to make the coefficient of y the same for both equations, what will end up happening is that we'll have to multiply equation 1 by 2 to make this 3 into a 6, and we'll have to multiply equation 2 by 3 to make this into a 6. We'll end up doing twice the work. Let's just multiply equation 1 by 4, so this x becomes 4x, and we can cancel it out with this one, and all we are left with is the equation with y. We can solve for y. So equation 2 times 4 times x is 4x. 2y times 4 is 8y, and 2 times 4 is 8. And now we have our equation 1, which is simply 4x plus 3y equals 13. That's all. That's all. Now, this 4x has a positive sign in front of it. This 4x has a positive sign in front of it. We're going to subtract. We'll subtract the second equation, the bottom equation, from the first equation. I don't mean to say second equation. We'll subtract the bottom equation from the top equation. And when we do the subtraction, we have to change the sign. This positive will become negative. This positive will become negative. And 13 has a plus sign in front of it. And that will become negative. Positive 4x and negative 4x be cancelled out. 8y minus 3y. 8y minus the 3y gives us 5y. 5y equals an 8 and an 8 minus the 13. This 13 becomes negative 13 because we're subtracting it. So 8 minus the negative 13 gives us negative 5. Divide both sides by 5 and y equals to negative 1. Voila. Y equals to negative 1. Now we have to figure out what is the value of x at that point. When y equals 1, what value of x will satisfy both equations? And since that value of x will satisfy both equations, it doesn't matter which equation we take, and just substitute the value of y, solve for x. I'm going to work with the second equation because it's simpler. So equation number 2 implies that x equals, if we were to take 2y to both 2y to that side, subtract 2y from both sides, the 2y ends up there, so it's 2 minus 2y, 2 minus 2 times y, which is negative 1, and 2 times negative 2 times negative 1 is positive 2, so it's just 4. There you go. We just found their point of intersection. Their point of intersection is where x equals 4 and y equals negative 1. That's it. Now we're going to show these two equations on a graph. We're going to show these two equations on a graph. I need the room, so I'm going to erase this part. We're done with all of this thing. We don't need any of this. We're just going to plot the graph. Now, in order to plot the graph of a line, of a straight line that is, we only need 2 points. We only need 2 points. We already know 1 point. The 1 point that we know is the point of intersection. So we can figure out 1 point from either of these two equations, and we can have our line, graph of the line. But I'm not going to use this point. I'm not going to use this point because that's the whole point. We want to show that if we were to draw the graph of the equation from these two independent equations, that they do in fact intersect at this point, 4 and negative 1. So there's no point in using the point itself. So we're going to solve them independently. The first equation was, what was the first equation? It was x plus 2y equals 2. Let's just find its x and y intercept. X-intercept is where y equals 0. X-intercept simply means what's the value of x where the line crosses the y-axis. If the line crosses the, x-intercept is where y is equal to 0. X-intercept is where y is equal to 0. Y is equal to 0, we're asking ourselves what is the value of the x where the line crosses the x-intercept, which is why it's called the x-axis rather. Which is why it's called x-intercept. I'm going to erase all of this thing because we need a room. I want to draw a nice graph. We're done with all of this. So let's first solve it here. X-intercept is where y is equal to 0. If we put 0 in here, we'll end up with x plus 2 times 0 equals 2, which of course simply means, which implies that x is equal to 0. Let's find the y-intercept. Y-intercept is where x is 0. So this is where the line cuts the y-axis. Wherever the line cuts the y-axis, the value of x is 0. And that's called the y-intercept. So here we plug in x equal to 0 in this equation, and we end up with 0 plus 2 times y equals 2, and therefore y equals 1. There you go. We have the 2 points we're looking for. We can plot it on a nice graph. We're going to draw a nice big graph so that we can show the intersection, and I'm going to do it here. We need the room. Negative 1 and 4, remember it. They intersect. Point of intersection. Point of intersection is, we just found it. Sorry, not negative 1 and 4, rather 4 and negative 1. 4 and negative 1. 4 is the x coordinate, negative 1 is the y coordinate. Now, when you're plotting it freehand like I'm about to do, no matter how hard you try, it's not going to be drawn precisely to the scale. So it's not going to come out exactly, but it's going to give you a very good idea. Let's do it here. So, there we go. X-intercept is where y is equal to 0. When y is equal to 0, x is... What the hell? Why does it say x is equal to 0? 1. When y is equal to 0, x is equal to 2. That's it. I don't know what this was. What was this about? That's it. It implies that x is equal to 2. Probably that's what I meant to write. That's what I meant to write. X is equal to 2. Right here, it says right here. Because 2 times 0 is 0, and therefore x equals 2. X equals 2. Here we go. 1, 2. There we go. That's the first point. Let's give it a name. Let's give this point a name. Let's call it point A. So that's your A, which is x is 2 and y is 0. X is 2 and y is 0. That's our point. First, that's the x-intercept of this line. Let's find the y-intercept. Y-intercept is where x is 0. X is 0 along the y-axis when y is equal to 1. Right here. Let's call it point B. Here x is 0 and y is equal to 1. There you go. There is your line. We found the first line. Let's draw a nice line. This is the tricky part. I have to make sure my... Okay, let's do the second line. We're done with this one. That's it. Let's do second line. The second line was 4x plus 3y equals 13. 4x plus 3y equals 13. Again, to find x-intercept is where y equals 0. That's why it's called x-intercept. X-intercept means where does this line cross x-axis. Wherever the line crosses x-axis, at that point the y is 0 because there is no y distance, which is why we say it crosses the x-axis. Plug in y equal to 0 in this equation. 4x plus 3 times 0 equals 13. 3 times 0 is just 0. So 4x equals 13, therefore x equals 13 over 4. We know 12 over 4 is 3, so it looks like it is 3 1/4. 3 1/4, let's find it. 3 1/4. So y is 0, and x y is 0 and x is 3 1/4. 1, 2, 3, 4. It's somewhere here. It's getting a little crowded, so I'm going to move this notation here. This is your point A. 3 1/4, let's call it point C. X is 3 1/4 and y is 0. Let's call this one point C. We're done with that part. Let's find the y-intercept. Y-intercept is where x is 0. If x is 0, that means we are not moving along x-axis at all. We are staying on somewhere on the y-axis, which is why it's called y-intercept, because that's where the line cuts the y-axis. Where does it cut the y-axis? At what distance of y? We'll find out. When x is 0, put it back in here, x is equal to 0. So 4 times 0 plus 3 times y equals 13. 4 times 0 is 0, so 3y equals 13, which means y equals 13 over 3. How much is 13 over 3? I don't know. I know 12 over 3 is 4. 12 over 3 is 4, so it's a 4 1/3. So y equals 4 1/3. Oh, it's going to be way up there. 4 1/3. Let's call this point D. Point D. Right here. 1, 2, 3, 4 and 4 1/3. It's going to go through these two lines. Okay, this is the tricky part. I hope I do a good job. Yeah, see, it wasn't a very good job because this line sort of curved. Oh, this is horrendous. This is horrendous. I don't like it. I'm going to redraw it. Where they intersect, we cannot see this on this graph. We cannot see this on this graph. because they intersect at, we already know they intersect at 4 and -1. What the hell? 4 and -1? Something is going wrong. It does not look like 4 and -1. It should intersect at 4 and -1. Something. I have not plotted my graph very nicely. But everything else is fine. The graphs are okay. It's just we did not do a good job on plotting them. So we're going to have to replot them. I'm going to replot them. Now that I know the point of intersection, we're going to replot them. The first one was, the first line has the first line has x-intercept and y-intercept of, oh, they right here, the first line was 2, 0. I just want to confirm it, that's what I have here. Yep, 2, 0. And x-intercept is 0, 1. 0, 1. 0, 1. That is correct? 2, 0. I'm just trying to figure out why it looks so much different than what it should look like. We know the point of intersection is 4 and -1. 4 is here, 1, 2, 3, 4. And -1 would be somewhere here. They should have intersected here somewhere. And the reason they are not, doesn't look like it, is because my draw is, as I told you, is not drawn very nicely. And you're watching all this thing obviously, because that's how we learn. We're going to redraw it, and at this time I'm going to take my sweet time and make sure we do a good job of it. And the second one was, so that was our line, first line. The second line we just found 3 and a quarter when y is 0. 3 and a quarter when y is 0. 3 and a quarter, 1, 2, 3 and a quarter, y is 0 right here. And 4 and a third when x is 0. When x is 0, it's 4 and a third. 1, 2, 3, 4, 4 and a third. 1, 2, 3, 4. It's not a big deal. We're just going to redraw the whole thing. We're going to take our time. I'm going to erase all of this thing. We're done. We have done the algebraic work, which is the finding out the intercept, which part is done. Now this is a matter of drawing it. We're going to redraw that. Take our time. 2, 0. 1, 2, 2, 0. And 0, 1. 0, 1. That's our first line. And the second line is 3 and a quarter, 0. 1, 2, 3 and a quarter. 1, 2, 3 and a quarter. One, 2, 3 and a quarter, somewhere here. And 0 and 4 and 4 and 1/3. 0 and 4 and 1/3. 1, 2, 3, 4 and 1/3. Somewhere here. Let's draw this. Keep your fingers crossed this time. Ah, voila, voila. There, you see? I did a sloppy job drawing this thing. I could, as I always explained to you many times in the past, if you watch my videos, when I make a mistake, very easily I could retape the whole thing, and no one would be wiser. But that's not the whole point. The whole point is not that you do it right the very first time. You make a boo-boo. People make boo-boo. That's what it is. To make boo-boo is human. So making a mistake is not a point. I did a sloppy job, very sloppy job drawing these two lines here. But here, let's see what happens. So, we know the point of intersection 4 and -1. 1, 2, 3. Aha! 1, 2, 3, 4. Looks like this is 4. Voila! And a -1. Voila! There you go. That's your point of intersection. 4 and -1. That's it, we are done. That graph, as I told you, is a sloppy graph. Just ignore it. Or, if you like, you can just say to yourself, this point of intersection is 4, 1 right here, but it's not drawn properly. Just ignore it. This is a proper graph. And that is the graph that you see at the bottom of the page number 236. That's how you draw it. And that's how you plot a graph. Again, notice when we're plotting the graph for these two lines, we did not use the point of intersection as our one point to help us plot the graph, because that would defeat the purpose. The whole purpose was to actually show that this, in fact, the whole purpose was to show that this, in fact, is the point of intersection. So we can't use it itself. So what we did is we used the two equations independently. When we were using the first equation, we had nothing to do with second equation. We found the x-intercept and y-intercept, the first equation. We plotted it. Then we found the x and y-intercept, the second equation, and we plotted that. And we just saw where does the point of intersection emerge. It emerges exactly where the algebra tells us, 4 and -1. That's it. That's all. We're done with this one. So it did not come out so badly after all. I will see you tomorrow on day number 121, where we'll continue with these geometry problems. There are still 2.8.3, 1, 2, 3. There are still 4 more problems before we go to the next part where we'll talk about how to plot functions. So we're getting there. We'll get there. Alright, I'll see you tomorrow. Bye now.